Yo no veo la pantalla. Bueno. Hi everyone, I am Luz Gomez of Silmar Marketing Department. Thanks for participating of the Silmar webinar. Today's webinar will be conducted by Marcel Van Brakel, IP Product Manager, and Daniel Gonzalez, he is IP Sales Engineer at Silmar Electronics. If you have any question, please enter in the chat and we will answer in the end. Daniel, thanks for participating on this webinar.
Thank you, Luz. Thank you. Once again, just to reiterate, if you guys have any questions, you can put them in on the chat, and we'll answer them at the end of the webinar. All right, so let's get started. So today we're going to be discussing all you need to know about IP video systems. We're going to go over 5 topics, and the 5 topics are: how do you correctly calculate, how do you calculate correct megapixel resolution depending on the scene? How do you select the right camera depending on illumination, or depending on on the scene itself, if there's too much or too little light? What kind of embedded MVR or server are you going to use depending on the application at hand? We're going to also discuss where do the recordings go, and how can we view those videos? And the last point we're going to go over is power and communication options. How do you transmit the video and data from your networks across to and from the camera and the MVR? So let's start off with talking about how do you select the right megapixel camera for your jobs. So as you can see here, just a quick recap as to what analog video looked like and IP video looks like now. You can see there's a lot more resolution, a lot better video, and a lot more useful image that we can actually use, in the event of some sort of playback that needs to be used. So there are 2 different formats in video that we see: the 4:3 aspect ratio and the 16:9 aspect ratio. Both, the 16:9 is a rectangular or widescreen aspect ratio. You can see it represented in the yellow box that says 1920 by 1080, whereas the 4:3 aspect ratio is more a square, kind of represented by the green 1600 by 1200 megapixel resolution. So you can see the different formats for that, as well as their respective resolutions that they come in. And the only note that we want you guys to realize here is that a lot of the cameras are coming widescreen, because that's what your eye is normally used to seeing. We're used to seeing wide images, not just a square. So you will see a lot more of these 16:9 aspect ratio cameras coming out, especially in the 4K to 8 megapixel range. That is the new resolution that you see in IP video nowadays. I want you to go over in the 4:3 aspect ratio. You have the 1.3 megapixel, 2 megapixel, 3, 5, and 10. And the 16:9 aspect, you have the 720p or 1 megapixel, 1080p, that's 2.1 megapixel, or 4K, that's 8 megapixel or more. So why not only use 10 megapixel cameras on all your installations? So the first reason you won't want to do that is obviously price. So the 10 megapixel camera is going to cost more than, say, a 2 or 1 megapixel. And like I said, you might not need all those pixels for that scene. Higher megapixel also consumes more bandwidth and more storage. So if you have 30 10 megapixel cameras, you're going to need a lot more storage than, say, 32 megapixel cameras. And we're going to go over why you want, or when to use these 2 different camera types. And the next point we're going to go over is the ability to capture light. So the lower megapixel cameras are able to capture light easier than a 10 megapixel. So in a tough lit situation where the room might be a little darker, although 10 megapixel would look better quality-wise, the actual image itself would be brighter, and using a 2 megapixel sensor. And the last note we're going to go over is frames per second. So the problem with high megapixel cameras is you're usually only limited to a lower frames per second. So typically a 10 megapixel camera will not stream more than 7 frames per second. And that might not always work for your customers. So let's go over another aspect called pixel density. And that also goes hand in hand with what's called pixels per foot. As you can see in the images to the right, you'll notice that at 20 pixels per foot, the image is blurry, progressively getting better until you reach 100 pixels per foot. What we want you to realize is in order for you to detect motion or detect a person is there, you only need about 6 pixels per foot. Detection means I know there's something there, something is moving, I just don't quite know what it is. The next is recognition, 32 pixels per foot. That means that you might already know the person, you might work with the person, they might be your friend, you're familiar with who they are, so you'll be able to recognize them even though the image isn't as great as, say, for identification purposes. In the event of the need to identify someone, most of the time that comes up in forensic work or in police work, you need to actually give them the best image possible so that they can run that image through a database and see if that face has come up before, you know, in any kind of database that way. And we want you to realize that you need 100 pixels per foot usually in those situations. And for license plates, you'll be able to read the license plate with approximately 40 pixels per foot. You'll be able to tell whether it's an L, an N, a 7, a 9, or an E, as you can see in the example there on the screen to the right. So in this example, we're going to go a little bit deeper as to what the differences are. You'll notice that with detection, 6 pixels per foot, the image is extremely blurry. But once again, I can tell you there's somebody in a jacket there. Next, what about recognition? In this image, once again, I would have had to have known who he was to be able to tell you exactly who the person was, but I can get a little bit more details as to maybe what he was wearing and also where, you know, his ethnicity, where he's from. And in the last image, identification, or 100 pixels per foot, once again, I don't need to know who he is. I can run that picture through a database and get a hit on who that person might have been. So how do you calculate pixels per foot? Pixels per foot are calculated by the horizontal resolution of the camera. In the case on the bottom, it's 1280 by the image width at the object itself. So that one's a little bit harder to explain. I would explain that by saying if the object is, let's say, 30 feet away from you, but the camera is capturing a width, so from one side of the camera of the view to the other is 30 feet, that's the number we're going to go for. It's not from the person to the object, sorry, from the camera to the object, it's the width at the object's distance. So with those two numbers, I can divide them and get my pixels per foot. Let's see what that might look like. Oh, sorry, before we go on, there's a website that we use called jvsg.com, and it's a great tool to use to differentiate with that camera, what view can I expect. You enter in the camera, its resolution, and its mounting height, and it's going to give you 3 colors: green for identification, yellow for recognition, and all the way at the end would be detection. So with this software, you'll be able to find out before actually going to do the installation whether you have enough pixels per foot to capture what you are looking for. So in this example, we have a 1080p camera that's 1920. It's horizontal resolution, and at the object's the view of the object is 60 feet. So we're looking at about a 60-foot area. If you divide 1920 by 60, you get a resolution of about 32 pixels. Once again, I would be able to recognize this person if I knew who she was, but I wouldn't be able to identify them if I didn't, because the image is kind of, as you can see, a little bit blurry. You can see the image to the right that's zoomed in. Once again, it's usable, but if I didn't know who she was, I probably wouldn't be able to tell you any more information. One more quick example is at the airport. So we're looking at a wingspan of an airplane that's about 100 feet wide, using the same 1080p 2 megapixel camera. If we get the 1920, and we divide it by 100, that gives us about 19 pixels per foot. Now let's bring the resolution down in the camera to 720. That's about that horizontal resolution of 1280. When we get 1280 divided by 100, we get an estimate of about 13 pixels per foot. And for standard definition, 8.6. That's 860 divided by 100 gives you about 8.6. Now, neither of these will work for identification or for recognition, but we will be able to see that there's a person moving. We'll be able to detect that there is movement, that there is a change in the scene. So how can we also have the DIA Tech calculator. You can write that website down. This is very similar to what we spoke about before, but in this calculator, you're able to adjust the camera's lens or its focal length to determine how I can get or what image I can expect from my cameras. And it also, as you can see the picture on the screen, it's going to give you a preview with that lens as to what you can expect. You can do it with a tag, or you can do it with this picture you see here. That way you can be sure that you have enough pixels per foot with the correct lens and megapixel camera for your scene. So let's talk about how we can improve pixels per foot. So the first way to improve pixels per foot is obviously increasing camera resolution. If you have a 2 megapixel camera and you buy a 5 megapixel camera, we have more pixels. Now we have more, now we also have more pixels per foot. But what if there's tough lighting situations like we talked about before, where higher megapixels won't work because we don't have enough light? So the next step would be, well, can we get the camera closer to the subject? Moving the camera closer might give you less of a view of the scene, but we are closer to the subject, meaning that now we have more pixels per foot. So we can get a better image. The next thing we can do is change focal lengths. So focal lengths would be, I have a camera that that's a varifocal lens. I'm gonna make sure that the lens is as closed as it can be to get as tight on that subject as possible and concentrate those pixels onto one area. Once again, you will have less of a view, but you will be concentrating those pixels in one area that will give you the better resolution that we're looking for. And the last way is using hallway mode. So hallway mode or corridor mode, some cameras come with the option to flip the aspect ratio of the camera. And what that does is pretty much eliminates the unnecessary wall view that we have in the top right-hand picture. And it converts it into the bottom right-hand picture, which is the exact same image, just instead of in a 16:9 aspect ratio, it's in a 9:16 aspect ratio. So all we did was eliminate all the unnecessary wall space and concentrated pixels as well. As a result, you can see the image on the bottom left. The first picture was not with corridor mode off, and the second with corridor mode on. Same camera, same lens, just the new technology that allows us to change that aspect ratio. So let's talk about a few technologies that we see in IP cameras nowadays. The four that we're going to talk about are P-Iris, wide dynamic range, smart IR, and low light cameras. These are technologies that we find very necessary in certain scenes. And we're going to go over where to use them and when they're most useful. So the first is P-Iris, or precise iris control. P-Iris controls the depth of field of the scene. Depth of field is pretty much what's in great focus depending on how open or closed my aperture of the lens is. So in the first example, you'll see that with aperture wide open, or at f-stop 2.8, the only thing in sharp focus is the middle of the object, or the middle of the scene, or as you can see, the cat sitting on a box. Now if I close the lens to f-stop 5.8, more of the scene comes in sharp focus. You'll notice that still the tree might be a little bit focused in the end, but not as focused as if we close the lens one more f-stop down to f11. Now you'll notice that in that last example, the whole scene is in sharp focus, or a usable focus. So One thing we want you to note is that depth of field will increase as the iris is closed, and you'll notice that with the example that we went over right now. So what's the difference, and where can I see this in live, and where would this really help me? You can see in the example on the screen that the red vehicle is in sharp focus, while the yellow and the green behind get progressively worse as the further the object is from the camera. So what if I wanted to see the entire scene in sharp focus? Well, then I would deploy a camera with precise iris control. In the example in the example to the right, you'll see that the red vehicle is in sharp focus, just as it was before, but now the yellow and green cars are also in sharp focus. And another feature with PIris that we want to discuss is that their camera can be in sharp focus during the day, but when the lens opens at night to allow for more light to come in, the focus will be blurry because of what we talked about before with the depth of field. So how does that look like in real life? Well, you can see in the image here to the left, the pumpkin in the front of the image is in sharp focus, but the WiseNet 3 sign in the back as well as the subject in the background are both out of focus. And this is because scenes with varying light, scenes with light coming from the outside in, causes the camera not to be able to focus on the whole scene because it has what's called auto iris or conventional iris. But if you had the same exact scene with a camera that has precise iris or PIris, you'll notice as in the right-hand side, not only is the pumpkin in sharp focus, now I can very well read the WiseNet 3 sign, as well as the subject walking toward the camera, also in sharp focus. So in usable terms, the image to the right is a lot more, will be a lot more usable than the one to the left. And here's a short video that goes over the same. With conventional iris, the duck is in sharp focus, but the background is all out of focus. I couldn't tell you what make and model that yellow car is. I can tell you it was more than likely just a taxi cab driver. But to the right, I can definitely tell you that the white car in the background seems to be a Mazda, a Mazda 3 maybe, white, whereas in the image before, it was just a blur. So the next technology we're going to talk about is wide dynamic range. So with wide dynamic range, I'm sorry about that. With wide dynamic range, where you employ wide dynamic range in one of two scenes. The scene you guys see on the screen right now, it's inside of a store. The camera is looking out. With wide dynamic range off, the camera is focusing or compensating for the bright light outside of the store, but is unable to compensate for the low light inside. And as a result, you have a black image that's pretty much dark on the inside and a whitewashed image on the outside. I want you to note that the only reason why the door that is closed can be seen through is because it has like a film or a tint on it. You'll notice that the subject in the front, oops, sorry about that, guys. You'll notice that the subject in the front is pretty much not invisible, but dark. I wouldn't be able to see her face with wide dynamic range off. Now with wide dynamic range on, you can actually see more to the image. There is a tree to the right-hand side. There's couches and sofas and seating areas that weren't visible before. I can see the subject's face a lot better, and as well as outside the scene is better lit, and I can actually see through the door. In this next example, we see it in a parking garage where the gentleman is walking toward a vehicle. I cannot see with wide dynamic range off him in any way, shape, or form. I can't see what he's wearing, any of his facial features. I cannot see past or outside the parking garage, and inside the parking garage is also very dark. But with wide dynamic range on, not only can I now see past the garage, I can see exactly the subject in question, what he's wearing and where he's from, as well as what's inside the garage is better lit. Look at the shading under the vehicle. You'll notice that with wide dynamic range off, there's nothing there. But with wide dynamic range on, I can actually see the shadows from under the car. In this next example, we want to talk about decibels for wide dynamic range. So wide dynamic range come, when you buy a wide dynamic range camera, they come in different decibel values, ranging from 75 to 160 decibels. The higher the decibel value, the more ability the camera has to fight these tough lighting conditions. In the example to the left, we have a 2 megapixel wide dynamic range camera with only 100 decibels of wide dynamic range. And to the left, we have a 1 megapixel camera with 120 decibel wide dynamic range. What we want you guys to note is the image to the left in the vestibules where the jewelry is held. You can barely see any details. Although it's a 2 megapixel camera and the image should have had more clarity, the problem in this picture isn't clarity, it's the light. So with a lower megapixel camera with better wide dynamic range, as you can see to the right, you are able to distinguish where the jewelry starts and ends. So the customer can pull out, or the employee can pull out a specific set of, let's say, necklace or bracelets, and in the right image you would definitely be able to tell which one they pulled out, versus in the left you wouldn't have been able to do the same. And in this last example, you can see that to the left it's an okay image. You know, I see that there is somebody there, I can see the background. But what about to the right? When we turn wide dynamic range on, in this case 140 decibel wide dynamic range, now I can actually see that there's a gentleman inside leaning up against the wall that we didn't see before. We also see that there's signage on the inside in the dark that we also didn't see before, as well as vending machines. You're also able to see the subject, or the female, walking closer toward the camera, and you can see her in better detail. I can tell you that, you know, better what clothing she was wearing. And the last thing is, look at the sign on the top left. I can actually read the letters on the sign, whereas before it was a lot darker. So once again, wide dynamic range is a camera's ability to fight these tough lighting environments. Now, how does it work? How does wide dynamic range work? Well, wide dynamic range works by taking 3 exposures. A short exposure, as you can see on the screen, that shows you the outside, or what's happening outside in great light and great detail. But the problem with the short exposure is that inside, being that there's less light, it comes out very dark. So the next exposure is what's called a normal, or an average exposure of the two. You'll notice that the outside image is getting a little whitewashed. The middle of the scene where the light was okay is getting a lot better, but still the subject inside is dark. So the last step is to get a long exposure. Just to reiterate, the outside is now useless. The middle of the screen has gotten a little more whitewashed, but finally I have my subject, or the gentleman on the right-hand side, in good lighting. So the camera will merge the 3 images and give you the final result, what you see on the screen. An image that is just as clear in terms of light in the foreground as it is in the background. All right, so let's move on to smart IR. So we all know that IR is a camera's ability to see at night. So infrared sends a light across the room, bounces against off an object, comes back into the camera. And that works great when everything is at a certain distance from a camera. But what happens if the subject gets closer to the camera? Well, with smart IR, the infrareds will turn their intensity down as to keep the subject getting closer to the camera in good lighting, but as a result, the background will get darker. And in the third example, you'll see exactly what I mean. You'll see that the person is in good lighting. I'm able to see her facial features. She's not all whitewashed out, but as you can see in the background, it's darker than the first exposure that we discussed. In this example, you'll notice with smart IR off at 15 feet, the gentleman is visible. At 9 feet, he's getting more whitewashed. I'm starting to lose details as to what he has on his shirt, as well as facial details. And at 3 feet, I lost every detail about him, but my background is still great. I don't need my background. I need the subject. So what do? I employ a camera with smart IR on. At 15 feet, no difference. But at 9 feet, you'll notice once again the background is getting darker while the subject stays in good lighting. Notice the difference in his shirt. And the next example is even more. You'll notice that between the two that I'm actually able to see his facial details. I can tell you that he's of Asian descent. I can tell you his shirt design. but once again, the background is out of the scene. In this short video, we're going to show you a little bit more in detail as to what we mean. So as you can see, as he gets closer, approaches the camera, I completely lose the subject. He just becomes a white object on my screen. But with Smart IR on, I never lose the subject. He can't get close enough to the camera where I lose any of his facial features or any of the features or even what he's doing or the activities that he's doing. As you can see in the scene here, he's going to pull a box out of the closet and walk away. With the Smart IR off, it just looked like he grabbed some random object. We don't know exactly what it is. Let's talk about low light cameras. Low light cameras are different than IR cameras. So low light cameras are color at night. They stay color at night, and they're able to do this by taking longer exposures. So longer exposure means that the camera's lens stays open for a longer period of time, allowing for even the smallest amount of lights to bleed into the lens and get a color image. The negative part of color at night is that it produces motion blur because of those longer exposure times. But the positives are also prevalent. As in the example, as you can see below, with IR on, the gentleman looks like he's wearing khaki pants. I wouldn't be able to tell you the details of his clothing, but I can tell you that he has glasses on. Certain details I can tell you. But in the left image, where you see that there is color, I can, with more detail, tell you his skin tone. I can correctly tell you what color clothing he was wearing. He was actually wearing darker pants and like a green sweater. Whereas with IR, I wouldn't be able to tell you those details. So they do have their ups and downs, and we'll show you them in the videos you're watching right now. With IRs off completely, they're pretty much an unusable image. It's very, very dark out. With IR on, the closer the subject gets to the camera, you can see they're getting a lot better view, but still, what color, any details are gone because of the infrared. Whereas with the color on the bottom, I lose no details as to what they're wearing. And in this example, you'll also see what they pick up. Whereas with IR off, I couldn't tell you there was anybody there. With the IRs on, I can tell you that somebody picked up a box, but I'm not sure of what. But with the color image, I can tell you somebody picked up a box that had an MBR in it. So it's just the ability to give more detail at night. All right, the next subject we're going to go over is remote or smart focus. So this is a new technology we see in a lot of cameras, and I specifically like it because I'm not a big fan of heights. So when it comes to adjusting focus on a camera, normally we had to either get a scissor lift or a forklift or a ladder, jump up there, and walkie-talkie or call your partner, and back and forth as to if the camera is focused or not. And the other negative is having to focus with the dome off. When you put the dome back on, sometimes the focus would adjust again. Well, the great part about this technology is I can focus the camera from an air-conditioned seat anywhere in the world as long as I have access to the camera with the dome on. That way I don't have to worry about my focus changing with or without a dome. I don't have to worry about doing any of this on top of a ladder in any complicated situation. Once again, I just deploy the camera and hit the autofocus button on the camera, and you'll notice that it'll go from a blurry image to a sharp focus. And the next feature is also zoom. You'll notice that you can also remotely zoom in and focus once zoomed. Okay, so panoramic cameras are actually coming out a lot. They're a little different than fisheye cameras in that most panoramic cameras will have more than one image sensor, 3 or 4. The great part about panoramic cameras is that we like to refer to them as PTZ replacements, because you can get an entire overview of a scene without having to pan or tilt or zoom. We all know that with PTZs, if the camera was pointing in the direction where something was not occurring, unfortunately you lost that scene. Whereas with these panoramic cameras, you get a great 180-degree view or 360-degree view of an area without the need of having to pan or tilt across the scene. and then you can digitally zoom in to a specific area that you might, a specific area of interest. Now another good feature is, or another good idea would be to deploy this camera with a PTZ next to it. That way if you did need to zoom in and get more detail of a scene, you're able to do that as well. We use these a lot in applications like stadiums and parking lots where there's a big area to cover, and you can do the same amount of coverage with only one camera. Another advantage of the technology is most VMSs only require one license for these cameras, whereas the same view could have been achieved with 3 or 4 cameras, meaning you would have needed 3 or 4 licenses, 3 or 4 cameras, 3 or 4 cable runs. That all costs money. With this one camera, it's one license, one cable run, and you get the same view. All right, in this next slide, we can see fisheye cameras. To the left, you'll see an undewarped fisheye view. It's that round view that some of you might be familiar with. So with a fisheye camera, you get one view, one lens, and then you're able to dewarp that view into what you see on the bottom left, which is a 180-degree view or a regional view of the area. You normally get 3 different views: an overview, which is the regular round view that we're used to, a regional view, which is a 90-degree view, and you're able to EPTZ like you would a pan-tilt zoom camera across the scene. And the last view is P for panoramic. With the panoramic view, you're able to see the entire scene, and you're still able to zoom digitally and pan or tilt across the scene digitally as well. The one thing we want you guys to remember with these is that the image directly under the camera will be in sharp, great focus, and the further out you go from there, you'll start losing a little bit of definition. And that's just due to the way that the fisheye lens works. Now, what if we sell a brand camera called Vivotech, and Vivotech has a technology that allows you to get a fisheye camera and pair it up with one of their PTZs, as you can see in the image to the right. Now, what would that do for us? In this video, you'll see that there's an operator that is drawing on the left-hand side a square around an area of interest, and the PTZ is automatically going to that area. The advantage of this is that with 2 cameras, I can not only get the entire overview of the scene, which is really the main reason why a lot of people like fisheye cameras, but being that I now have it hooked up or working alongside a PTZ, I can also get the detail the detail and better quality resolution that I might expect from an IP camera. So this is where, once again, a great example of 2 cameras working together to give you an overview as well as a detailed view of a scene. Sorry about that, guys. So in this example, you'll notice the difference between night vision and thermal cameras, and we're going to be talking about thermal cameras. So for thermal cameras, the reason why we employ thermal cameras versus any other camera is for detection, for seeing somebody in either no light or minimal light. With night vision gets the available ambient light and amplifies it. The problem is, as you can see in the scene that we're looking at, if the person isn't moving, you really wouldn't be able to tell where he is. Whereas with thermal, since the cameras do not rely on light at all, they rely on heat signature, you can easily see the subject walking right in front of the trailer. Let's continue playing the video a little more to get another example of what we mean. In the next video that'll come up, you'll notice that there is actually, sorry about that, guys. You will notice that there is actually someone in front of the camera with a dog under him. In night vision, once again, because he's not moving and because there's very little light, you're unable to see where he is. With thermal cameras, because he cannot hide from his heat signature, I can easily see him. The only thing that can fool thermal cameras is if the person is behind an object. Remember that thermal technology cannot go through objects, can't go through glass, and it really won't work great if it's heavily fogged. But beside that, for perimeter protection, for detecting someone in your property that any other camera, any other color camera cannot do at the distances that thermal can do, that's why we always offer thermal cameras for those solutions. All right, now we're going to talk about license plate cameras, and we get this question asked a lot. Can we use license plate cameras for, or a regular IP camera as a license plate camera? And the answer is both yes and no. Yes, a regular IP camera will work for capturing license plate during the day. The problem is at night. So most license plate cameras at night are high contrast or black and white cameras and have special infrared that is designed to reflect off of license plates and come back to the camera. And once again, I'm going to put a little side note there and make you guys realize that that is the most important part. The license plate has to be reflective. If it's not a reflective plate, the IR will not bounce back into the camera, and you won't be able to see the subject. But going back, can you use an IP camera? Yes, you can. During the day, it will work. At night, unfortunately, because it's not a high contrast camera, you won't be able to see the images that great. So that's why we employ license plate cameras that are specifically designed for the job. These cameras are also able of capturing 2 lanes. A 3 megapixel camera is able to capture 2 lanes up to 120 miles an hour. And in this video, you can see a software that's actually employing a license plate camera and automatically recording plates as they drive along. The reason they do this is for easier searching of video. If I have the person's license plate, I can input it into my system and find the video of when I drove by that car, time, date, and even where the car was parked or location. And the next part you'll see is a vehicle comes up in Amber Alert. Amber Alert, or the car is stolen or reported stolen. With this software, if you do end up driving by that vehicle, it will flag you that you had found this tag, and the tag was being flagged for, in this case, missing child. So, all right, so let's talk about embedded and servers with software installed and when to use them. We're not going to go too deep into what exactly the differences are. As you can see on the screen, there are a few differences, but let's go more into when do we use these. When do we use these 2 different systems, and why really we choose one versus the other. So one thing we want to talk about is applications that are up to or under 16 cameras. In this case, we would normally recommend what we consider a direct replacement to a DVR or an embedded NVR. The embedded NVR is usually going to have PoE built in directly to the unit, so it's just like a regular DVR installation. You're home running your cables from the cameras to the NVR, or if that's not possible, you can also do it, as you can see on the image, via a PoE switch in between. In either case, you're usually limited to how many or to what cameras you have. Note that you can always let us know, and we can help you guys in determining what cameras to use with these embedded kits, but there are very few options available. So in a medium-sized application, 16 to 32 channels, the NVRs change. Normally, these NVRs will not have PoE built in. That means you would have to employ an external PoE switch. These recorders require licenses per camera, and that's one of the added features that are the great features of these units, is that if I have a customer that starts with 18 cameras but in the future wants to grow to 32, you only purchase the 16 licenses he needs, and as he grows, you continue buying licenses. And that is the ability to expand the systems. And the last part we want you to note is also, as you can see on the right-hand side, is client software or mobile apps. On these units, mobile apps are a lot stronger. You're able to drive more users and also be able to push out different layouts to different users. And the last system that we're going to talk about are applications over 32 cameras. And these are applications that are more server-based. Once again, you still have the same pay-per license, so you're able to upgrade the system, through its entire life. They have multiple network cards, so you can share your bandwidth load across multiple network cards. We're going to go a little bit. We're going to go talk a little bit more about RAID in a second. RAID is redundancy for hard drives. But once again, these systems are just going to be designed to handle more throughput, meaning you're going to be able to put more cameras on these systems. And we want to reiterate, if you have any questions, any design help, we are always here to help you guys choosing the right system for your jobs. Okay. What about if you have a customer that wants video, access control, and alarm integrated into one system? So we can help you with that. As you can see on the screen, we have a product that integrates CCTV, which is ExactVision, with Cantech, which is access control, with DSC, which is the alarm. The good part about this is that you're able to search video based on somebody's credentials versus not just date and time. Or you can also have a security guard monitoring a screen that's able to when somebody opens up a door, a screen will come up with the camera nearest the door to make sure that the person who's beeping in with the access control card is indeed that person, and he didn't give his access control card to his friend or his neighbor, or it got stolen or anything like that. So the great part about these integrations is that, once again, you can have visual verification across multiple platforms. So how do you select a recording device? A lot of things go into selecting a recording device. Things like, what kind of integration is a customer looking at? How many customers are going to be connecting to his system or clients? How many sites are going to be using the system? What cameras does he have? Is the MVR compatible with the cameras that are existing there? Or the camera that he needs in that specific situation, is it compatible with a certain VMS? These are all things that need to be taken into consideration when building systems, and also we can help you with this as well. As per workstations, we want to let you guys realize that with the introduction of high definition video, our workstations, or the computer that is going to be remotely viewing this software, or sorry, these recordings, need to be a lot stronger. So if you have a customer that says, I have this 10-year-old Dell computer, I'm going to use that as my client computer, unfortunately the bullets that you see here are probably missing. It might not have good enough network card, it might not have enough memory or a good enough processor, it might not have a video card capable of handling all that video, and it might not have a hard drive big enough to save that recorded video. Okay, so, and also take into consideration for video walls that there is a maximum number in some softwares as to how many monitors you can connect to these clients. Okay, now where does all this data get saved or stored? So we're recording all this data. Where does it get stored? Well, in this case, we're showing you a server that is capable of holding 96 terabytes of storage. We're actually at 8 terabyte hard drives right now. So 8 terabyte drives times 12 bays gives us 96 terabytes of raw storage. What we want you guys to realize is that if you have a customer who's demanding maybe 60 or 90 days of recording, this would be the option for them. A server that's capable of holding all this storage. And once again, you have the benefits of multiple processors and redundancy through RAID and power supplies. Once again, we're going to go over RAID in just a moment. So one thing we want to have you guys realize is that not all hard drives are built the same. There's usually 3 hard drives you're going to see in our industry. They're not the only 3 hard drives that exist, but they're the 3 that we always use. The first is a purple, or what's called a video security drive. Western Digital calls it their purple drives. Seagate calls it their SV35s. The difference between this and a regular hard drive, let's say a desktop hard drive, is first, these hard drives are designed mission critical, meaning they're supposed to run 24/7. They're designed to never be turned off. The next thing is these hard drives are designed to write in bigger blocks. Because video is so big, instead of writing smaller chunks or smaller bits of data to the drive, these drives have a special firmware installed that allows them to write longer bits of data across the entire hard drive. That way, once again, you're not losing any speed on writing smaller bits of data. Now, as per the RAID or the Enterprise class drive, the next set of hard drives, you'll see them as Western Digital Reds or Seagate Enterprise NAS drives. These hard drives usually have same thing, mission critical, they run 24/7, except they have two controllers, a reading controller and a writing controller. And the reason for this is just, once again, speed. These hard drives are going to be recording and also reading data constantly throughout the day. So because of that, they added redundancy and two different controllers to handle that workload. And the last hard drive you'll find is solid state drives. Now, we only recommend these drives for the operating system. You don't want to use this to record video because they do have a limited number of times you can rewrite on the sectors of the drive. So what that means is that after a while, that hard drive will fail. Also, there's a limited capacity in drives. You notice that SSDs are just now getting into the terabyte zones, and they're also extremely expensive. So you definitely want to keep those solid-state drives just for the operating system. So I said we were going to go over RAID. We're going to go over it as best I can here. I want you guys to realize that there's different forms of RAID. In any case, the two that we're going to discuss today is RAID 1 and RAID 5. I want you to see on the left, you'll see RAID 1 and how it works. It literally makes a carbon copy using half of your disks. So in the example, we have 8 4-terabyte hard drives. That gives me a total capacity of 32 terabytes. But because half of those drives will be utilized as a backup of the other half, I can actually only write 16 terabytes of information across those 8 4-terabyte hard drives. The good part about it is, if I do end up losing half of my hard drive array, I have an exact replica waiting and more than likely gonna boot up in that event. But with RAID 5, it's still the ability to, once again, have a redundant system, but we don't have the loss of hard drive space we do with RAID 1. As you can see in the example, we have the same 8 4-terabyte hard drives, which gives us the same 32 terabytes of storage, except now I only lose one hard drive's space, and that gives me the ability to record 28 terabytes. How does it do it? Very similar to RAID 1, except it divides the information across more disks. And once again, in the event of a loss, there is enough data across the rest of the disks to continue on. The only problem is that the system will not operate at its full speed. Yes, you can only lose one hard drive. And once again, when the hard drive is down, you're going to notice a lack of speed, because the system is now, is getting the workload of what the 8 hard drives had, and is now only putting it onto 7. How do you get your performance back? By reinstalling a fresh disk. What that'll do is it'll now re-input that fresh disk with all the information that was missing, and now your system is back up and running. So that's the two different versions of RAID that we always try and stick to. We usually stick RAID 1 for our operating system to make sure that the system does fail, it can operate back up again all over again. And then we use for the video storage RAID 5 as to not lose any space, or as much space, should I say, as RAID 1 would. So we wanted to introduce you to a software, it's not a software, it's a website that's for storage and bandwidth calculation called exact.com/config. In this software, you can enter how many cameras you guys are going to be using for the job, its compression, its resolution, how many frames per second, how many days of recording, and the strangest is recording percentage. And that's if you're going to be either 100% recording, which is continuous, or if you're going to be recording on motion, let's say at a house that's got very little motion, 40%, or at a business that has high motion, maybe 60%. You have to use your best judgment, or you can always include us in the quote, and we can help you as best we can in determining how much hard drive space you need and how much data and storage rate is necessary on the servers. And once the information is inputted, you'll notice on the bottom left, you'll get 3 pieces of information. That camera data rate, which is how much throughput is needed on the MVR to live view the cameras. Storage data rate is how much throughput is needed to store the information coming from the camera. And storage required is how many terabytes do I need to store however many days and however many cameras I have. So moving along, how do we transmit, the data across our networks? Let's talk about PoE. So there's usually two versions of PoE that we'll find in our industry. So you'll see PoE and PoE Plus. The difference is that PoE is going to give you a max of 15.4 watts, while PoE Plus a max of 30, but you also see PoE Plus in 60 watts as well. One thing that we do run into a lot is budgeting for PoE. And the budgeting is extremely hard, especially when objects come with what's called class codes. And I'm going to quickly brush up as best I can as to what that means. So let's say, for example, I had a camera that consumed 7 watts, but it's a class 3 product. We want you guys to realize that although it only consumes 7 watts, because it is a class 3 product, it's going to reserve on the switch 15 watts. The reason why it says 12.95 watts is because that's already taken into consideration the loss of power because of the length of the cable. So when we're budgeting for PoE, we have to also take into consideration that class, because I cannot budget 7 watts for a class 3 item. I have to actually budget the 15 watts. It's max load, because that's what the camera will reserve. The two different kinds of PoE devices you'll find are end spans and mid spans. So you're probably very used to seeing end spans, which is just a switch, but it also has the capability of powering the cameras as well. The mid span is pretty much a PoE injector. Now, we get a lot of questions of why would you use a PoE injector or a mid span? Why just not use PoE switches? Well, we find that in some of the bigger installations where there was an existing layer 3 switch, or the IT department wants your system to be installed on a VLAN, you're not going to resell them switches. All you need to do is keep their switches, like you see in the example here. So there's going to be a switch on the head end. Then you're going to run an Ethernet cable into the input of either the midspan or the PoE injector, which will then input power coming from the power supply of the injector, and then on the output port push over not only data as well as power to the camera. So once again, if you have a situation where the end user doesn't want to replace their switches, or they have very good switches, you're going to go for the midspan option there. And in this last slide, we're going to go over the 5 commonly seen communication methods that you see in the industry today. The first 3 are Ethernet, and we see that in Cat 5 or Cat 6. We know that it's got about a 1 gig max throughput and a 320 max distance. And that's the standard media. We all know what that is. But what about wireless? We get this asked a lot. We're not going to go too deep into wireless because there really isn't a solid answer for distance when it comes to Wi-Fi, because it depends on construction material, it depends on distance from the router or the wireless device, as well as what frequency was used in the setup. But the only thing we can guarantee you is that you're going to typically get no more than 25 megabits per second across that wireless signal. And the next thing that we want you to realize with wireless is that there's no such thing as wireless power. Well, I want you to realize that because if you're already running a power wire to the camera, there might be an existing technology that we can employ that's not wireless. And that way, once again, you don't depend on that wireless frequency. The next mode is fiber optic. Fiber optic is great for transmitting data across long distances, from 1.5 miles to 25 miles, and you're going to get anywhere between 1 to 10 gigabits per second across that line. But the only thing is that you cannot transmit power across fiber. So fiber, once again, is great for linking buildings that might be miles away from each other, where you don't need where Ethernet's normal 320-foot max distance just doesn't cut it. The last 2 forms of transmitting video are legacy, or what I consider legacy cable. They've been around for a very long time. and we don't want you guys to throw them away or be discouraged as to not using them. With coax, which is RG59 or RG6, we sell a transmitter and receiver that allows you to transmit not only power, but data as well across up to 3,000 feet of coax. And I'm not talking about Siamese cable. I'm talking about literally only using the coax, the RG59, to transmit both, again, the power and data across up to the 3,000 feet. And I keep on reiterating up to because there is a little bit of a max, and we'll go over what the maxes are in a second. But the good part about it is, once again, if you have a customer that had coax or analog cameras before, and they don't want you to, destroy their infrastructure, you don't have to. We have a product that you can use right alongside those cables. The same goes for the UTP cable or the twisted pair. You have a transmitter and a receiver on one end of the on each end of the cable, and they're transmitting power and data across the line. For both cases, you're only going to have a max throughput of about 100 megabits per second. Now let's talk about those distances that we talked about before. I want you guys to realize that with power, the longer the distance, the less power can be transmitted across that cable. In the left, I'm going to use 30 watts as an example, high power. If I have a 30 watt PTZ camera and I'm using RG59, the most that I can transmit that power through is 984 feet, as per what the graph is showing me. So what we want you to realize is, yes, you're probably going to be able to transmit data across that line to 3,000 feet, but power is going to be where you might not be able to reach those extreme distances. So keep us in mind in those jobs, as we can definitely help you in pricing that out. And to the right, the same goes for twisted pair. The distance is greatly shorter with the is greatly decreased with the power, with the higher power cameras. All right. So we want to thank you guys for joining us on the webinar today. On the screen, you'll see the sales team for the Caribbean and their emails. If you guys want to write them down, and you have any questions, any concerns, any product questions, you can definitely contact them. And I'm going to move on to the next screen. Just 1 second. I'm going to go back to this one. I'm Daniel Gonzalez. I'm the second down. We're a team of 4 IP engineers. We design systems. We help you guys in any tech support after the installation as well. So we want you guys to have our data in there, our information in there, as well, in case you have any projects you want to include us on. Let's get into the questions here. Let's see if there are any questions. Once again, I don't see any here. I just wanted to see if there's any. You can always write it into the chat, and we can help you guys with those questions. But other than that, once again, I want to thank everyone for joining us today. I hope you guys learned a lot, and it was my pleasure talking to you guys. Thank you very much.
Daniel, thank you very much for the excellent presentation.
We're still here. Like I said, if there are any questions, let us know. We're still on the webinar.
Lo terminé.
Oh.
Bueno. Anyone have any question? Daniel, thank you very much for the excellent presentation. If anyone has additional question, please feel free to send me an email at latam@silmarelectronics.com. Thank you very much. A happy day for everyone.
Thank you, Luz.
Thank you, Daniel.
Guys,
Ay, perdón.
For technical services. So once again, that's why we put on the screen right now the tech team emails. So if you do have any technical services, if you're in need of design help for a system, please write our emails down. We will be more than happy to help you guys out. Thank you guys and have a great afternoon.